Right, in this video we're going to find the point of the intersection of a curve y is equal to x squared minus 3 and the circle x squared plus y squared is equal to 9. Now if we look at this, here we have the circle, and if we move the curve, we can see the curve will either not intersect at all. It could intersect at one point, the quadratic there at B, or it could intersect at 2 points, B and C, or it could intersect at a third point, which is that one there, or it could intersect at 4 points here. Okay, but we got the particular curve y is equal to x squared minus 3, so it's going to intersect at 3 points, and that's what the algebra should show us. So there's a diagram. So if we substitute y is equal to x squared minus 3 into the equation of the circle, x squared minus plus y squared is equal to 9. So what we're going to do is we're going to replace y in here with x squared minus 3. So you get x squared plus x squared minus 3 is equal to 9. Now, so what we need to do is expand this. So we've got x squared. If we expand this, x squared times x squared, which is x to the 4, we get minus 6x squared plus 9 is equal to 9. To solve this, we should put it equal to 0. So we're going to have x to the 4th. We've got x squared minus 6x, which gives us minus 5x squared. And if we take 9 from both sides, we're going to get 0. Now, there's a great temptation to divide this through by x squared. If you do that, you're going to lose one of your solutions. So you should always try to factorize. And anyhow, x could actually be equal to 0, which makes that not possible to do. So common factor of x squared, we're left with x squared minus 5 is equal to 0. If we continue to factorize, we will recognize this bit here, x squared minus 5, as a squared minus b squared, which is a plus b, a minus b. So we've got x squared brackets x plus root 5. Square root of x squared is x, square root of 5 is root 5. We should be frightened of working with thirds. And x minus root 5 is equal to 0. And therefore we're going to get three solutions from that. That x is equal to 0, x is equal to minus root 5, and or x is equal to 5. Now to find the y coordinate, it's obviously better to put back into the curve. So when x is equal to 0, we're going to get that y is equal to 0 squared minus 3, which gives me y is equal to minus 3, which is probably that point there. When x is equal to minus root 5, we're going to get y is equal to minus root 5 all squared minus 3. If you square a square root sign, we're just going to get 5 minus 3. 5 minus 3 is 2, so that's going to probably give me that point there. And then when x is equal to root 5, we're going to get that y is equal to root 5 squared minus 3, so we're going to get 5 minus 3, which is going to give me 2, which is probably going to give me that point there. So the points of intersection are minus root 5, 2, 0, 3, and root 5, 2. And on our diagram, those points are going to be minus root 5, 2 is there, 0 minus 3 is there, and root 5, 2 is there. Okay, so this has been a video to show you where a quadratic intersects a circle. I hope you've understood. And the GeoGebra applet I will put in the notes of this video. Thank you very much for watching.